Welcome to week 11 for INST 414. The announcements for this week. So first, regarding your semester project, everybody who has submitted their intermediate report reviews, I have shared out your reviews with your fellow students. So what does this mean? So it's now time for the peer evaluation step for your semester project. So over the course of the semester, I've been doing most of the evaluations for your project, but now we get to ask your input for your fellow students about what you think your fellow students' main contributions are, what is the value and interest in this work, what are its core strengths and weaknesses. So to do this assignment, you should have received emails with reports to review. I've only sent these emails to people who submitted reports. So if you haven't submitted a report, you haven't received this email. This is the way I do the matching. But if you have not received an email, reach out to me as soon as possible so we can discuss how this part of your assessment for the course should work. But in your email, you should get a rubric document and an anonymized group report. So these G0087 values, these are randomly generated IDs for the groups, so they don't map to the original group number. This is how we maintain some amount of anonymity at this stage in the evaluation. So what I want you to do is read over the review and fill out the rubric. So this rubric has 5 or 6 main pieces where you talk about what the main contribution of the project is. Is there any sort of evaluation is there any sort of mention about related approaches for this problem? What are the key strengths and weaknesses of the project as you see it? And what are the main insights being extracted? And how do you think that those insights might be used? Since, remember, as a data science course, we're all about generating useful and actionable insights. And then finally, at the end, what letter grade would you give this report? Note at the top there is reviewed group ID. There's a blank space for that, so you should put in the G0000 number, whatever the number associated with the PDF I sent you is, or in the subject of your email. And then you should put those two documents together, those two or however many reviews you have together, into one document and submit it via the interim report reviews assignment on Elms. And that's how I'll evaluate or collect your submissions and evaluate them. So that's due April 22nd, which is in 2 weeks. Now, there is no room for being late here because once you pass these reviews on to me, I will quickly aggregate them and then pass them on to you or back to the original project team so they can integrate those results or integrate those comments into their virtual presentation, which is due at the end of the month. So that's it for the semester project. Assignment 3. So assignment 3 is about identifying similar items and ranking them. So I have a walkthrough for the similarity notebook on YouTube. I've linked to it in the Python walkthroughs here for Module 3. For Module 4, we're working on the walkthrough for a simple k-means example. It should be up this week, and you'll be able to find that. This week, we start Module 6 on supervised learning. So I'll go through the learning objectives for this module, and then next week I'll talk about the assignment associated with Module 6. So the 4 learning objectives for this week are, first, be able to differentiate between classification and regression. So in Module 4, we talked about unsupervised learning and differentiated between unsupervised and supervised learning. Here, in the context of supervised learning, we'll talk about 2 general types of supervised learning, where we're trying to classify things into bins or categories or some sort of label, versus regression, where we're trying to predict or recover some scoring value. The next is to be able to describe how voting is used for k-nearest neighbors classification. So k-nearest neighbors is one of the simplest supervised learning techniques, where we have a bunch of points that have features associated with them, and each one of these points has a label associated with them. And using distance functions from what we talked about early on in the course, you can find, well, what are the 5 most similar neighbors to my new data point, and what are the values associated with them, and how do we vote to make the aggregate or final prediction for our label or for our class. And you can actually use k-nearest neighbors for regression as well. We'll talk about that. Also, be able to differentiate between the different kinds of classification. So you might generally think of classification as this binary task, either yes or no, is this email spam or not spam? But you can also have multi-class classification. It's actually similar to the clustering approach, where binary classification might be considered clustering with 2 clusters, or graph bisection, whereas multi-class might be considered clustering with multiple clusters, or more than 2 clusters. Alternatively, you might say multi-class classification is, or another example is image recognition or object recognition in images, that there are many kinds of images out there, many kinds of objects in images, and a given data element, like an image, might fit into a photograph kind of image, or a drawing kind of image, or a painting kind of image, or a cartoon kind of image. So that's multi-class, where the space of labels is generally larger than 2. In contrast, you also have multi-label classification, where you can have a given or a single data element has multiple output labels. And we'll talk about examples of that as well. And then lastly is defining overfitting, and talk about how it impacts generalizability. So there's a sweet spot between being able to generalize well and being able to recover the exact data in your training set, which is something we'll talk about. But that'll run us through the first part of this module. In the second part of this module, we'll go a little bit further and talk about regularization and how it can improve generalizability. This is how to deal with overfitting through regularization. And then we'll talk about linear regression models, and from the section in the book on linear models. Then we'll talk about how linear regression can be adapted for classification. So basically, how do we take a linear model like linear regression or logistic regression, and then adapt that to classification, which leads us into, rather than just performing a sharp evaluation of whether a data element receives a particular label or not, which is a like sharp decision function, you might also be interested in the probability of the output. So I don't necessarily want to know just whether an element is in class 1 or class 2. I want to know the probability that it's in class 1 versus the probability that it's in class 2. So we can use naive Bayes for this, and we'll try and join these pieces together from our probability example last module to this module on supervision. So those are the things, or where we're going over the next couple of weeks. For next week, I want you to be reading about linear models and then uncertainty in classifiers. So this is not a huge amount of reading, but the linear models section of chapter 2 is quite long. I want you to primarily focus on the baseline linear model in logistic regression, because that's what we'll use next week, but the discussion about regularization also pops up in there as well. And then the uncertainty estimates for classifiers is how we move from just doing classification to doing or capturing some amount of uncertainty in the data. So if you have any questions about anything in Module 6, by all means reach out, come to office hours, post in the discussion forums, the standard kinds of things.